Hello there. In this video, I will explain what Kerberos is and how it works. Kerberos was named after Kerberos, the three-headed dog of Greek mythology, because of its three components: the KDC, the client, and the server. So what Kerberos is an authentication protocol in client-server environments. So in other words, it is a protocol used to identify two participating elements in a network, for example, a client and a server. How does Kerberos work? To show how it works, I will use this diagram that I took from my favorite security book entitled Network Security Essentials by William Stallings. You can download and read this book. Okay, so let's see how Kerberos works. So as you can see in this diagram, we have the three heads of Kerberos: the KDC, the client, and the server. Now, to make sure that the client is a legitimate client, we should authenticate the client before granting access to a service in the server. How do we do that? The first message, as you can see, is the client requesting a ticket granting ticket. Basically, this is a ticket asking for another ticket. This ticket granting ticket is used as a ticket for the next server to ask for a service ticket to the server. Now, after the authentication server receives this message from the client, it verifies the user's access right in the database. So this AS has usernames and passwords of all clients in its database. So after getting the request from the client, it verifies the user's access right in the database, creates ticket granting ticket and session key. It checks if the user is a member in the database, and then creates ticket granting ticket and session key. The ticket and the session key are encrypted using key derived from the user's password. To be specific, it is hash of the user's password used as a key to encrypt the ticket and the session key. It sends the encrypted ticket and session key to the user. Now, to access this message, the workstation prompts the user for its password and uses the password to decrypt the incoming message. Because the message was encrypted using the hash of the password of the user, the workstation uses the password the user enters, hashes it, decrypts the incoming message, and it finds a ticket and the session key. Now, after decrypting the message, then the workstation sends the ticket as it is, the ticket granting ticket or TGT, and an authenticator, which was created by using the session key. Now, the authenticator contains user's ID or user's name, network address, and timestamp. So this workstation sends the ticket, the TGT, and the encrypted authenticator requesting service granting ticket. Now the TGS can read the ticket using a long-term key that it shares with the AS. After decrypting the ticket, it finds a session key. So AS sends a session key and copy of this session key embedded in the ticket for the TGS. So the same session key is sent by AS for the user and the TGS. So there is another session key, a copy of it in this ticket. So after TGS decrypts the ticket, it finds the session key in this ticket, and it uses that session key to decrypt the authenticator, which contains the user ID, network address, and timestamp. And by the way, the ticket, the TGT, contains ID of the user or user ID or username, the TGS ID of the target server, its network address, and timestamp and lifetime of the message. So that's what the ticket contains. And as I told you, the authenticator contains some of those values: the user ID, network address, and timestamp. So the authenticator contains all the elements in the ticket except lifetime of the message and TGS ID. Now, the TGS decrypts the ticket, finds the user ID, its ID, the user's network address, the timestamp, and lifetime of the message. And the session key is one of the elements in the ticket. After decrypting it, that's what the elements are. So those elements in the ticket plus a session key. Now, using the session key, it decrypts the authenticator. It decrypts the authenticator, it finds these three values, then it compares the values in the ticket and the authenticator. So as I said, it decrypts the ticket and the authenticator, verifies request, In other words, it checks values in the ticket and authenticator match, then creates ticket for request server. In other words, the service granting ticket. In addition to the ticket, it sends similar like what the AS did. It sends a session key for the client and the server, like the AS sends a session key for the client and for the TGS. Now, Kerberos uses a symmetric key encryption. So in other words, every pair, every communicating pair, or every element in this protocol should have the same key in order to exchange messages. So first, the AS and TGS share a master key, a long-term key, and the TGS and this server share another long-term key. So these are permanent keys. So these three elements share permanent key. So the AS with the TGS share a permanent key, and the TGS with the server share a permanent key. To decrypt the ticket, okay, so as I told you, to decrypt the ticket, TGS uses a permanent key that it shares with AS, and similarly, the server uses permanent key that shares with TGS to decrypt the ticket that this TGS sends, or in other words, the service granting ticket. In addition to those long-term keys, Kerberos uses session keys. So this AS sends session key to this user, and the same session key, copy of it, is embedded in this ticket that TGS finds after decrypting the ticket. And this TGS again sends a session key to the client and copy of it in the ticket, which will be read by the server. So after the TGS sends the service granting ticket and session key to the client, the workstation of the client sends this ticket, the service granting ticket, and an authenticator to the server requesting service. Now the server verifies the ticket which was sent by the user, which is the service granting ticket, and the authenticator, which was encrypted using this session key. Now this server decrypts the ticket and the authenticator. It decrypts the ticket, as I told you, by using the long-term key that it shares with TS. It finds the elements in the ticket, including the session key. Using the session key, decrypting the authenticator, it compares the values in the authenticator and the ticket, then grants access to the service. Now, if mutual authentication is required, the server returns an authenticator. So if the client requires that the server should authenticate itself as well, the server takes the timestamp in the authenticator and increments it by 1 and encrypts it by the session key it found in this ticket, the session key that it shares with the user. So it encrypts the authenticator and it sends it to the user. The user will decrypt and read the authenticator and makes sure that it's talking to the right server. So as you might have understood already, the ticket is used to distribute session keys. So this ticket, the AS embedded a session key for TGS, which is the same copy of the session key that is shared for the user. So in other words, the AS sends a session key for the user end, the TGS, and it sends the session key to the TGS by using the ticket. And similarly, the TGS embeds a session key, this session key, copy of it, in this ticket, and it reaches to the server. So in other words, as you can see, the ticket is, in other words, used as a way to distribute session keys. So it doesn't authenticate anyone. The authenticator does. So the authenticator is the one that identifies participating entities. Finally, at the conclusion of this process, the client and server share a secret key to encrypt future messages between them. So after authenticating each other, the client and server need to exchange messages, right? Now to do that, they share a secret key to encrypt future messages, or to exchange a new session key for that purpose. To have a session key, a temporary key for message exchanges, a key that uses for temporary message exchange, they use a secret key to create that session key, and then they continue talking to each other securely. Alright, so that is all I have for this video. Don't forget to like and subscribe. I will see you in the next video. Bye.